Hello geometry students, and welcome to the proof of the 30, 60, 90 triangle theorem. So what this is a special case of the Pythagorean theorem with a triangle that has some special characteristics. It has an angle that is 30 degrees, an angle that is 60 degrees, and an angle that is 90 degrees. And what it says here is that given this triangle, the hypotenuse is twice as long as the shorter leg. So I've labeled them here. A is the shorter leg, B is the longer leg, and C is the hypotenuse. So this is the hypotenuse, this is the shorter leg. So A there is the shorter leg, and B here, this is the longer leg. Okay. And what we're trying to show, what the theorem says, is that the hypotenuse is always twice as long as the shorter leg, and the longer leg B is the same as the shorter leg times the square root of 3. And we're going to prove both of these results. So I'm going to prove part 1 first, because this is probably the more challenging of the two parts. After that, it's pretty straightforward. Okay. And with these proofs, it's pretty difficult to kind of come up with the first step on your own. Whoever thought of this, probably had to put a little bit of thought into it. So I'm going to give you kind of the first step and walk through this together. So first, what we're going to do is duplicate this triangle. Let me name this thing. I'm going to name this A, B, and this right triangle here, C. Okay. So we're going to construct a triangle that is congruent to triangle ABC. And I'm going to do that in a very simple way. All I'm going to do is use my ruler here, using the ruler postulate. So however long this length is, I'm going to duplicate it down here. And I'll call this new point D. And then I'm going to connect D to A. And so what we have is, triangle ABC is congruent to triangle ADC. Okay, so ADC is the one we just constructed, and that's congruent to the blue triangle right here. Okay. And really, that's the most important step. The reason we're able to do this is Euclid's first and second postulate. Okay. Or it's also called the ruler postulate. So now it's important to make some observations here. If these two right triangles are congruent, then that means this angle up here is congruent to this angle down here, so they are both 60 degrees. Okay. Next, if you notice then, this angle here is 30 degrees, so this angle down here is also 30 degrees. Okay. So these are true, these are both 60 and 30 by CPCT. Okay. So I'll make a note here, angle D, the measure of angle D is equal to 60 degrees. And the measure of angle CAD is equal to 30 degrees. And this is by congruent parts, or corresponding parts of congruent triangles. Now, if we look at the entire picture here, triangle ABD, the big one, then it's pretty clear that it's an equal angular and equilateral right triangle, because that angle is 60, that angle is 60, and the big angle here is also 60. So step 3, triangle ABD is equilateral, because all angles are 60 degrees. Okay. And if that's true, then we can make some more observations about this triangle. Next, we can say that BA here is equal to DA. This must also be equal to little c. And this length here, BD, is also equal to c. So I'm going to start out by saying that BD is equal to c. Okay, because this is the transitive property. Because BD is equal to BA. Now, keep in mind, this is what we want to show right here, that C is equal to 2A. So we have to get 2A somewhere in this process. But if you look at the two smaller right triangles, we said that the red one down here is congruent to the blue one up here. So that means this length right here, these two little lengths, CB and CD, is also equal to little a. So from the picture, it should be clear that BD is also equal to A plus A, or 2A. BD is equal to A plus A, or 2A. And this is the segment addition postulate. So for our final step, we take these two expressions for BD and we tie them together, and we have C is equal to 2A. And there it is. That completes our proof of part 1. And the main step in all of this is constructing a triangle that is congruent to the original blue one. Now I'm going to go on here and finish the proof for step 2. And this proof is pretty straightforward because we're going to use the Pythagorean Theorem. And if we just look at the original picture, this original triangle ABC here, we get that A squared plus B squared is equal to C squared. And this is the Pythagorean Theorem. Okay, that's just the Pythagorean Theorem. And we want to somehow get rid of C. We have an expression with A, B, and C, and we want an expression that only uses B and A, so we want to replace C with something. And the nice part about this is that in part 1, we were able to find an expression connecting C to A. So instead of writing C, we can just substitute in here 2A. Okay, so this is the substitution property here. Using part 1. This is substitution using the result from part 1. And from here on out, it's just algebra. A squared plus B squared is equal to, this on the right hand side is 4A squared because it's 2A times 2A. Subtract A squared from both sides and we get 3A squared. And then take the square root of both sides. So if we just take the square root of both sides here, that's a property of square root. We get that B is equal to the square root of 3 times A. Or sometimes I just like to write it with the letter first. Okay? And there you have it. That is the end of this proof. Well, so thank you for watching. There are some other examples in the assignment here that shows you how to apply this theorem. But the main idea that we get from here is that there is a relation, a very special relation, between the hypotenuse and the legs of a 30-60 right triangle. As always, keep working on these ideas, these proofs. They are challenging, but if you can understand the proof, you can solve problems more efficiently and quickly, and math tends to make a little bit more sense. Have a wonderful evening.